Welcome, Happy New Year's, and welcome back to the Caribou Data Science channel. This is a do-over from the give me 1 second here.
Disappear from social media and do this instead. Become a master of AI tools with 20
Hang on 1
AI
second. I need to
First, stop scrolling.
turn on the sound. I had a problem the other night again for the first time in a couple months with my YouTube live stream, but it was unavailable. I got the dreaded, stream 54 years ago message, which means it's basically dead. Okay. So tonight, I'm connecting to it. So tonight, what we're doing is I'm going back to watch my, to actually setting my two devices, a laptop Well, look at that. Maybe we got two people in the chat. Wait a minute. Actually, one is my phone and the other is my iPad. So, so anyway, if you're on the background, it's actually pretty important that you actually stop by because we need to let YouTube know that people are actually taking part in my live stream. That's very important. Okay. So by all means, stop by the chat and just say hi. Okay. Now, anyway, we're coming back to the. We're back to my Slackware 15.0 desktop, Anaconda, and IBIS. Okay. Now, let's come back over here for one moment. Go to Home. Now, you can set up under the .IPython directory. You can set up a config file to preload things, and the only thing you need to preload is this, because that right there takes the place of several other import statements, like the lib IBS and stuff like that. Then we just simply load our two plotting libraries. Okay. Now tonight we're actually going to be using Jupyter. My friend, Rabbit Q, how are you doing this evening? Recommended to you by who? Thanks so much for stopping by. And who it was that recommended it, be sure to tell them I say I really appreciate that recommendation. It means a lot to me that people are actually recommend me to their friends. Okay, what we're doing tonight, we're going to use a Python package called IBIS. Okay, and IBIS is an interesting package. It's designed to be a common API for various types of backends. Okay, so IBIS can be used to connect to, say, Duckdb, which is its default backend. It can be used to connect to SQL Server, to Postgres, to MySQL, to all these different backends. While we're here, let's just take a quick look at their page, okay? Okay. So what it does, it allows you to run. So YouTube recommends you. Very good, very good. It's actually important that people. So now you got to invite one of your friends to join the channel also, okay? But I really do appreciate it. So, do you live in India? The first name to me it sounds like an Indian name. I could be wrong. So anyway, so what you do is you use IBIS. What IBIS does, it takes Python code or a subset of Python code, and it converts it to SQL, and then it runs it against the back end. Now, what's interesting is we're not actually creating a table on a database. We're simply using the Duckdb back end to run the code. Of course, Duckdb is small and fast and very easy to work with, and there is a couple ways to actually use IBIS. You can do it. One of the main ways is to use IPython. Okay. Then you could say the right arrow completes the statement. So this says from IBIS interactive import everything. Okay. Then we could say import matplotlib. IPython Seaborn. And what this first statement gives, as you'll see, it gives us access to a couple of different APIs. It's part of IBIS. Okay. So. Two of the things that this first statement gives us access to, it gives us access to what's called the s.selectors, which is very similar like dplyr commands like contain, functions for working with text strings, things like contains or begins with or ends with and stuff like that. It also gives us access to an underscore function, which what we do is we only have to name the data frame once, and the rest of the statement we can use an underscore period column name to access it. So let's just try something here. Let's just try. First of all, just for the fun of it, let's come over here. Let's take a look at our data. Using, of course, using Emacs to look at the data. Now the problem we see here is with the name, how the columns are named. Okay, so we want to convert. So the first function you're going to use now is one called rename. And what it does is it's going to take these names, convert them to lowercase, and then when there should be it's going to place a underscore between the two names. Okay. So that's our first thing. By the way, the subject again is avocados and now we're going to start here, but we're actually going to quickly switch over to using the Jupyter Notebook. Okay, but Has is the avocado, the most common avocado you see in your store shelves. And that's the initials of the guy who actually developed this. Because originally, basically an avocado consisted of a pit and basically a skin. But the avocado you see today with this nice thick meat to it and stuff like that, that's strictly this guy named Has. So the first thing I'm going to do is notice we're using the IBIS, not the standard Python function, because by using the IBIS command here, it's going to run it against the Duckdb database in the background. Oh, this is kind of interesting. Am I not in the right place? Now you can run a shell command. Okay, so it was right. Okay, and there's our thing. I guess we're going to say HASS. Okay. And the first thing we want to do, we want to fix the names. Rename. We want to use the snake case. Is it snake case? I don't think that's right. Let's see. Well, maybe it is. And the first thing you notice is this nice little formatted table here, okay? And that comes from the IBIS interactive function, okay? So next time we actually want to take a look at the schema. And the only columns we're interested in date, total volume, let's see, type and region, okay? So we're going to say IBIS dot. Now our next function is we're going to get rid of the unnecessary column. Now again, this is where the underscore function comes in. Underscore, instead of typing, there's three ways. I could do this, right? Or I could do this. There's three ways to do this, and I can't remember what the other ones are. Okay. What we're going to do is, what that import statement did allows us to substitute an underscore followed by the name in a column. So it simplifies making select statements and stuff like that. So again, it's underscore dot region, comma, underscore dot type. Type, by the way, is either conventional or organic, okay? So I believe total volume is the total volume is measured in pound, and I think the average price is the average price per pound, okay? And so total volume would be the total pounds. So we can say, let's see, well, let's go ahead and include, because should we do total volume or should we do total bags? Well, by the way, the region is kind of interesting because it contains more than regions. Okay, specifically, it's like over here. It includes California as a region, and we got the rest of these regions here. Now they also have a total numbers for the total U.S. Now apparently, the regions and stuff don't add up. Okay, the numbers in the regions don't add up. Average price, I don't know. Let's do total bags. See if this works. Okay, so now we got our stuff here. Okay, now at this point, let's just keep going with here. At this point, we can say dot. We can say, let's see, something like this. If you use dplyr or R at all, tidy versus R, this is exactly the same as the first thing we're going to do. We're going to look at we're going to calculate the average price per day. All right. Dot ag. Let's call it mean price equals underscore ABERAGE. Now here's your second tip. In order to use the plotting function Seaborn and Matplotlib, you have to convert this table to a pandas data frame. Okay, because it actually uses its. Let's take a look at something really quick. Let's take a look at the type what Haas is. Let's do this. Let's see what type of object Haas X. Okay, so you can see it's an IBIS expression type relations table. So it's a table, but it's not a pandas data frame. So again, go over here. Okay, dot ag. And again, I'm not sure. I think this is maybe the average price per pound, maybe, which would make sense. Total bags and stuff like that. Let's see. Mean price underscore period average price dot. Again, now this part here should look you want to always order it. So let's see how this looks first of all. So there's our mean price table, but now we have to come back over here, run it again, do a 2, okay. So we look at this again. Now it looks like a pandas data frame. So now let's just do a quick plot by day. All right. Let's see. So start date. Date. Price. Region is subject for another plot. So tell me, my friend, are you a student? Are you actually a productive member of society working in data science or something? What's your current situation? Now, for that work. Now, in order for this to work, show. Let's see what this looks like. So here's our plot of average price by day from 2015 to 2020 to 2023. Now, hopefully, within the next couple of weeks, the Haas Avocado Board, which is the lobbying organization for the avocado industry, will post the numbers for the end of 2024. Okay. And of course you can do that. You can assign titles to it. You got grids, X and Y labels. I've done that before. So that's just basically. So that's your basic workflow. All right, that's your basic workflow. Now let's come back up here. Let's change this. Okay, type. Now we're going to do this, and we're going to do it by okay. So this will give us one row for each date for each type. Again, type is either conventional or normal, or it's organic. When you see the results of this plot, you'll be like, I'm never going to buy organic fruit again. Just wait till you see the price difference average between the conventional, the regular avocados, and the so the only difference between these two plots is HUE equals underscore dot. I think this is right, unless I may have to put a single quote about this. I can't remember. Now brace yourself for a sticker shock, okay? Well, what do we have up here? Make sure this is right. So that looks okay, doesn't it? Let's do this. SNS dot x equals, right? Again, the period represents the data frame. Oh, no, okay. We don't need this here because the data frame is named separately. Although we probably could do it actually. Okay, so the reason this didn't work is because of the dot period. We don't need the dot period, right? But I'm not sure whether or not we need the quotes, we need the single quotes around that or not. It's taking a moment to think. Okay, let's do one more thing. Let's do a oh, this is interesting. I don't understand. This isn't the way it's supposed to work. There's supposed to be one line for the average, one line for the. Now this is a very interesting plot. I just don't know what it represents, because there should be one line for the organic and one line for the regular avocados. Did we miss something here? Maybe we do have to put it inside a single quote. Yeah, so here we go. Conventional avocados versus organic avocados. Now I ask you, is it really worth? Is that now? What's the difference? You're talking here between. Well, if you look up, what are we actually talking a difference at? Well, you're talking from here. Well, let's start. Let's start over here. 1.14 average price up to 1.6. So I mean, so it's not a big jump. It's less than a. It's maybe what is it? It's maybe 50 cents per pound, possibly, or more. But there, I mean, is it really worth it to get the organic for when you have this big of a price difference? Okay. Okay. What else do we have back up here? Oh, I made a fatal mistake. Oh, crap. I made a fatal mistake. I forgot to exclude. This is all the data from all the regions plus the total for the U.S. That's not what we wanted. We only wanted to we only wanted the total U.S. region. Crap. So let's try filter, comma, underscore, period. So let's see if this works. Okay. So what we can actually do here, we'll get a little funky here. We'll just come back up and recreate the code again. How about that? Okay. So let's do this again. Now again, you can actually run this just fine in a Jupyter notebook, okay? Mean price date. Does this work? So here is the average price by date simply for the U.S. total numbers, okay? Let's come back down there then. Let's look for average price. Average price type. Okay, and here's our average price just for the U.S. just for the total U.S. Now what it says on the page is, well, the numbers don't actually add up. So apparently all the regional code numbers don't add up to the total U.S. code. All right. So where are we now? Let's take a look at total bags. Okay. Yeah, we can look at total. I was going to say average bags per day. We can look at total bags. Okay, so let's do this. Let's see. Dot. Again. You know that. I hope you noticed that underscore trick is really a good trick to do, because you can have really long you can have really long descriptive names for your data frames, and all you have to do is use an underscore. Okay. And the aggregate function is just pandas. That's all it is. Okay. So ag. I tell you, because I like you, we're actually going to do two things. We're going to do the total bags here, and we might as well just use the comma, total bags dot order by underscore dot So let's start with a new plot here. Dot equals y equals that's total equals and this is the total bags by day, okay? Of course, this is 1 to the 7th, so you're talking a lot of avocados there, right? Let's do one more. Let's look at mean. Okay. So this is the average number of, or maybe the average number of pounds, right? So we're looking at total bags, right? So this must be the average number of bags sold per day, all right? But we're still going to the 6, so that's 1 plus 6 zeros, right? So that's 100,000. So is this 600,000? No, this isn't right. This must be like millions. Okay, is that right? Because if the individual numbers, well, no, this is the average per day, so this would be an average of 800,000 sold per day here, okay? Let's take a second look over here. So this is to the 7th. So this is 1 million. So that means that back in sometime during 2017, avocado sales peaked for a single day at about 1.6 million bags, or whatever it is, pounds. Okay. Well, let's do one more thing here. Let's do type again. Over here again. Okay. Let's come back over here. This is total. So now we come over here and do a comma, UE equals okay. Let's see what this looks like. Oh! This is interesting. What's this again? Total bags? Is that what this is? Is this total bags? No, this is interesting. To me, what you look at here is that even though, look at the difference between the number of bags sold for conventional versus organic. You know what? I may have to. Title. So the organic, you know, you know, wow. Needless to say, the conventional market pretty much has got a corner on the on the market. I mean, look at the difference between the number of organic bags sold, okay, right, and the number of I suppose the good thing is about the organic is that you have a nice consistent number of units being sold. The bad news is it's flat. There's a lot more volatility in the there's a lot more volatility, but a lot more volume in terms of bags for the conventional bag, for the conventional as there is for the organic. That's pretty amazing to me. Are you still there, Rob? Okay. And that, my dear friend Rob, again, thanks so much for stopping by. Thanks for YouTube for recommending the channel to you. And also, Rob, be sure to invite one friend this week. I'll be back on Friday to do some more analysis with the Furniture Mart dataset in Python. Okay, so by all means, mark your calendar for 9 p.m. New York time, Friday evening. I'll be back at it again. Maybe you can rest assured I am going to be doing more with the IBIS, because I really like IBIS a lot. I mean, look what we've done here in 30 minutes. Okay. Also, by the way, if you have a data set you'd like me to take a